guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Before we proceed, I'd like to appreciate our members and kindly request that we subscribe, engage ourselves in the comment section, and also ring that notification bell to be getting updates on our various uploads in mathematics and sciences. Now, in our discussion today, I'm going to look at one of the properties of transition elements, and this is their ability to form what we refer to as a catalyst. Now, in our previous discussions on the concept of activation energy and the various, of course, topics under the concept of enzymes, we have looked at some of the examples of elements and the compounds which are going to either speed up the rate of chemical reaction, or in some cases provide a surface area over which these specific reactions are going to take place. Now, these are going to be the catalytic properties that we are going to investigate, especially when it comes to a transition element. And in this particular case, we are going to see that many transition metals are going to form, or in their compound forms are going to form or have catalytic properties. And we're going to mention a few, of course, and try to give one of the reasons as to why, or particularly a reason as to why these particular metals are going to possess these catalytic properties. Now, of course, I've mentioned the concept of the enzymes, and those are going to be biochemical processes which are going to be involving these specific enzymes. Now, for catalysts, we're going to see that one of the characteristics that is going to be associated with this particular catalyst is that they are able to form numerous oxidation states. Now, the transition elements are able to form numerous oxidation states, and therefore this is going to allow them to form catalytic, or to have catalytic properties by having these numerous states. Now, this specific condition is going to be forming unstable intermediates through which some of the reactions are going to be taking place. Now, this is one of the reasons as to why these particular elements are going to possess catalytic properties. And another one, of course, we're going to see that these particular elements can provide a service over which these specific reactions are going to take place. And perhaps give this one in terms of a statement, a summary statement form. So one of the properties is that this oxidation, the particular transition elements are going to have numerous oxidation states, and therefore they are going to, of course, form unstable intermediates through which, sorry for that, through which, of course, these reactions are going to take place. And of course, they are going to provide suitable reaction services over which these particular reactions are going to take place. And in this particular case, we have mentioned the concept of hydrogenation, especially under the concept of organic reactions or organic synthesis. And this is one of the examples of which we're going to see one of the transition elements that is going to provide, of course, a suitable service, or suitable reaction service over which this particular organic reaction is going to take place. Now, some of the metals in the transition element family is going to be having metal ions, which are going to act as, of course, so these are going to be metal ions that are going to act as coenzymes. I've mentioned the concept of an enzyme. So these metal ions in some of the biochemicals are going to be acting as coenzymes, which are going to catalyze different biochemical processes. And these are some of the characteristics or the reason as to why some of these metals are going to be having these catalytic properties. Now, we're going to mention a few of these, or some of these specific compounds which are going to be involved in various chemical reactions, and of course, or biochemical reactions. And of course, we're going to look at perhaps mention some of the processes in which these particular, of course, compounds are going to be involved. So, for instance, if I look at this specific compound, this is an oxide of manganese, which is used commonly in the production of oxygen. And we have looked at particularly the laboratory preparation of oxygen, whereby we have mentioned this one as one of the catalysts, or the main catalyst, which is going to be used in trying to, of course, facilitating that particular reaction. Now for the production of sulfuric acid, we are going to have this oxide of vanadium, and this is going to be of course used in the production of sulfuric acid in this particular case, and this is going to be just having the same relevance as the first, of course, example we have given for manganese oxide. Now we're going to have some of the combination of platinum or rhodium catalyst, and this is going to be, of course, used in the production of ammonia or in some reactions which are going to be involving ammonia given as such. And of course, we are going to look at another one which is, of course, going to be relevant in the Haber process, which is going to be iron molybdenum, and this is going to be used in the Haber process, also in the production of ammonia, just as I've given for this one. And as well, we're going to have a Ziegler-Natta catalyst, which is basically the compound of tin halide. So we shall have a tin chloride. Of course, this is going to be this is not going to be tin, this is going to be titanium. So we're going to have this one, titanium chloride, being used as Ziegler-Natta catalyst. And we mentioned this one in our organic synthesis, so I'm going to have this one written as this. So this is going to be a Ziegler-Natta catalyst, and this is going to be the chloride of titanium given as such. And as well, we are going to have another compound which is going to be used in the Wacker process. Now the Wacker process is going to use this specific compound of palladium chloride, given as this one. So we're going to have this one, Wacker process. And lastly, maybe I may mention this specific compound, which is, or rather this specific transition element of the name of nickel, that's going to be used as René catalyst. And of course, this is basically used in the reduction processes, which we are going to come across in some of our discussions. So basically, these are some of the of course, transition elements in terms of compounds, or of course, a combination with other transition elements going to be used as some of the catalysts using some of the chemical processes or biochemical processes that we're going to come across. And I've mentioned, of course, the concept of coenzyme, whereby the metal ions are going to act as coenzymes in biochemical processes. Perhaps we can give just a few examples of those ones, so that in case we come across them in our various discussions, then it's going to be elaborate for us the role of those specific metals. So we're going to have a metal combining with an enzyme, and this is going to form what we call a metallo enzyme. For instance, we are going to have an example of a zinc 2. So this is going to combine with an enzyme, especially in the metabolism of alcohol, to form a dehydrogenase, and this is going to be one of the alcohols or enzymes which are going to be involved in the metabolism of alcohol. And then we are going to have this iron molybdenum, and which is going to act as a coenzyme in nitrogenase, which is an enzyme used in the fixation of nitrogen and the nodules of legumes of or leguminous plants. So this is going to be nitrogenase, of course, which is used in nitrogen fixation in plants, as I've mentioned. And therefore, lastly, we can perhaps mention another one, which is of course manganese 2, which is used in agnese. Agnese, this is an enzyme that is used in urea formation. So in this particular case, these are some of the examples of particularly three, of course, metals which are going to act as coenzymes in particularly biochemical processes. So this is going to be alcohol metabolism. And then this particular enzyme of the hydrogenase, which I mentioned in my previous statement. So kindly check our description boxes for various links of other videos which we have done on the concept of transition elements. And together with this specific aspect of catalytic properties, then we're going to appreciate the overall aspect of these transition elements in our day-to-day applications. And of course, we're going to apply them appropriately in case we come across them in our program sets, in our various discussions in the preceding videos. So this is it for now, guys. Kindly subscribe and engage us in the comment section, and also ring that notification for more details on various discussions in mathematics and sciences. So that is it for now. Bye. God bless. We catch us in our next video.